All right, here is problem 2 in the section on uniform distributions of continuous random variables. It's about waiting for a bus. It says that the times that people wait for a bus are uniformly distributed between 0 and 15 minutes. And then it asks 3 questions. So in order to answer them, let's go ahead and draw that distribution. Let me draw it 3 times, okay? So here it comes for problem A. It's all going to be the same, by the way. Here's 0 over here, here's 15. Let's answer problem B right here. And problem C right down here. 15 and 0. So first of all, you might note that in each case, of course, I've drawn the same distribution. It's the same distribution, 3 different questions. I didn't label what this height is here, and it's always the case for uniform distributions that the height is 1 over the difference between the maximum and the minimum. This is called B, this is called A, right? And this height is always, in this case, 1/15th, which is B, it's 1 divided by B minus A. Okay, so that value is 1/15th, this value is 1/15th. This value is 1/15th. And that comes from the fact, right, that the total area underneath the distribution curve needs to be 1, right? Because that's the restatement of the fact that the sum of all the outcomes of an experiment is 1, right? I can't stress that enough, that has to be the case, right? If that's not the case, when physical laws are not obeyed, reality itself cannot exist. Do you know who said that? Mr. Spock said that. So, take it to heart. And for those of you who don't know, Mr. Spock was a character in a famous science fiction series called Star Trek. But that aside, let's go ahead and do these problems. The first one says, what's the probability that someone waits for less than 12.5 minutes? So here's 12.5 right here. The question is, what's the probability that if you reach into all the people who waited for a bus, you found somebody who waited for less than 12.5 minutes? And I think you can see, or I want you to be able to see, that this area, this area under this curve is that probability. The probability that, we'll say x, is less than 12.5 minutes is just equal to the area under the curve, which is 12.5 times 1 over 15, which I could be wrong about this, but I think it's 0.388. Go look at your answers. But that's very important for you to get that visualization that the area under the curve is the probability of the random variable, a random variable selected from all the random variables in the distribution is in that interval between 0 and 12.5. And the probability is in this case, this area, which is this height, divided by times that width. All right. So the second problem, I'm having trouble remembering what the second problem is. I know what the third problem is. So the second problem says, what's the average time waited, okay? And that you can just sort of appeal to the fact that for uniform distributions, the mean is always A plus B all over 2, which in this case is 7.5. Okay, that's the mean, mu, and the standard deviation is B minus A squared all over 12, square root of that whole mess. Okay, and finally, last problem says, what's the probability, or what is the time at which 90% or less of the population waits, if I didn't say that particularly well. In other words, what is P90? And so what you're interested in is this value, which is 90% of the total value. So, the 90% of the total value is just going to be 90% of 15 in this case, right? And what is that, 13.5 hours, I believe, or minutes, I believe, if that's the case. Okay, I hope these are getting through. These are not terrifically difficult problems. I just want you to be able to see the relationship between the area under the curve and the probabilities being discussed. Okay? All right, this final problem of the three problems on uniform distributions is about a spinner problem, right? So spinner is a little plate with an arrow that you can flick and let it spin around and it'll stop somewhere. And this particular spinner is fairly numerical. It goes from a point 0 to 1/2 all the way around to 1. And we're being asked about a couple of different areas. One area is 0 to 1/2, so this is the top where x is between 0 and 1/2, and here's the bottom half where x is between 1/2 and 1, if you kind of get that. And it's asking about the little pie slice right here that's between 1/6 and 1/3. Yeah? And the problem, as you can read above, is given. I don't know that you see that it says the word given. Given that the spinner is in the upper half, it says we know that the spinner is in the upper half. It then asks, what is the probability that it has come to rest between 1/6 and 1/3? Okay, so the thing about the spinner, right, is all numbers, 0 to 1 if you will, are equally probable, right? And so if that's the case, there's a distribution between 0 and 1 that I guess is 1 high as well too, which is the uniform distribution, which describes how these random variables, the numbers on the spinner, are distributed. And, you know, again, they're all equally probable to happen. And so there's the uniform distribution. So let's see now if we can interpret for ourselves what the question is. And the question I tried to kind of give the answer to you is, given that the spinner is in the has fallen in the upper half, what's the probability that it falls between 1/6 and 1/3? So what's the probability that it falls somewhere in the region between, or the interval between 1/6 and 1/3, given that it's in the region between 0 and 1/2? You understand that's a different question than asking what's the probability that it's between 1/6 and 1/3, right? This is the question we're being asked. So if you remember these conditional probabilities, you can do them one of two ways. You can do them very directly. You can, because you see that given that you're in the upper half, ignore the bottom half, right? Ignore it, it's gone. You've just reduced the sample space. And now ask yourself, what's the probability that the spinner falls in this area given that it's in this area? Let me do that here. So here's 0 to 1/2. We're going to ignore this part, and here is how will I do this? Here is I don't know where 1/3 is. Here is 1/3, and here is 1/6. Okay. So what is this probability? Well, it's this area divided by that area, right? It is, in terms of those areas, this area 1/3 minus 1/6 divided by this area 1/2. And what's that? You know, I'm going to deal with fractions. Oh my God, it's 1/6 all over 1/2. I'm pretty sure that's 1/3. Okay, 1/3 is the answer to our question, and didn't show you that last step, but I'll let you figure that out. Okay, and we can think of it like that, or we can think of it formally in terms of the conditional probabilities. Remember, if this is event B given A, there's event B, here's event A, then this is just the probability of event B and event A divided by the probability, divided by the probability of event A. Okay, so let's now go to our uniform distribution and find all of those. What is the probability that you are at once between 1/3 and 1/6 and and between 0 and 1/2? Well, it's that area right there, isn't it? Right? It is that probability. Let me come right down. Let me write it down here. That probability is this dimension times 1. So it is 1/3 minus 1/6, and times 1 if you want to say it's that area, divided by the probability that you're between 0 and 1 is this area, wonk, 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 and that is 1/2 times 1, base times height. 1/3 minus 1/6, base times 1 times height, all right? And that is again 1/6 all over 1/2. I'm going to multiply the top and bottom by 2 over 1. I'm going to get 1 down here. I'm going to get 2 over 6, which is 1/3. And there's the answer both ways. Okay, so you can get a little bit more sophisticated with these uniform distributions, at least with regard to finding conditional probabilities. Okay, let's move on to the next section of the mastery.